In the unit of electrochemistry, we talked about a voltaic cell, which is essentially the simplest components of a battery used to produce electricity. I want to run through and label some of the components of the most basic type of voltaic cell, and then describe how it generates electricity. In looking at the system, we're going to start by identifying our two electrodes. The two electrodes are the pieces of metal that sit within the beakers and are connected by the wire. These metals are often found on Table J of your New York State reference tables, and you can use Table J to identify where the electrons are going to travel to and from. At the electrodes is where we're going to have the specific redox reactions occur. If I have copper and zinc as I do here, I can look on Table J and see that zinc is higher on Table J and will therefore lose electrons to the copper atom, which is lower. If zinc is losing electrons, those electrons will pass through the wire and travel to copper. By losing those electrons, we can say that zinc is being oxidized. Oxidation happens at the anode, so this side is my anode, where oxidation is occurring, making my copper cathode, where reduction is occurring. Again, the sayings to remember these, an-ox and red cap, will help you identify where the electrons and where the process of redoxes are occurring. Beyond just the transfer of electrons, there's another two components that are vital to actually producing electricity. The most notable one, or the one that the Regents exam wants to make sure you know is a vital component, is the salt bridge. The salt bridge allows for ions to travel back and forth across the two cells, keeping the system electrically balanced. Without the salt bridge, the salts that are within solution in your beakers become unbalanced. You have more positives on one side, more negatives on the other, and the system eventually will stop. In order to keep that balance, the salts are allowed to flow quite naturally through the salt bridge. The salt bridge can be something as simple as a piece of paper towel soaked in salt that allows the salts to transfer through osmosis. Again, to tie that together then, within the two beakers, you want to have a salt solution so that those electrons can be gained or lost by atoms and the actual reaction can occur. At the surface of the copper, since it's gaining electrons, these copper ions in solution will actually stick to the electrode, and the copper electrode will become larger and larger. Similarly, on the side of my zinc, as the zinc begins to lose those electrons, my zinc electrode breaks down, and the electrode becomes smaller and smaller. The production of electrons here, again, comes from the transfer of electrons from one element to another through a redox reaction. If we were to include a battery within the system, and make this all in one beaker, now we're talking about an electrolytic cell. Electrolytic cell drives the reaction backwards since it drives with the battery, and causes those elements that would normally lose to gain and those that gain to lose. In the electrolytic cell, you're going from the low part of Table J to the high part of Table J.